record, and then share screen. Share screen, this one. Okay, so we will continue our discussion about inheritance, is it? And if you recall the example we discussed, is it commission employee? But anyway, if we draw, here comes the wheel. Okay, so here, why am I, okay. So here we have the root of all of Java class object, is it? And then we have commission employee.
No way.
So I don't have an employee, is it? So that's coming. And then here we have the base plus. Is it base plus commission employee? Is it? So that's the subclass of commission employee, is it? So this is a super class. Okay, so that's a hierarchy regarding inheritance.
Did you start the recording?
Yeah. Yesterday
Okay.
I forgot. Double check. Okay, let me double check. How? Then I need to stop sharing.
Yes, it's recording.
Yeah, it's recording. Yeah, and reshare. Hold on. Yeah, yesterday I forgot. Here. Okay, and then you remember for our base plus commission employee, is if you want to define some class, a subclass of the other class, or here, commission employee, you need to use the keyword extends. Okay, extends explicitly. So then this means this is a super class. And this is subclass. Okay, the relationship. And in subclass, we just define base salary, is it? And this is base plus commission employee. It's constructor, is it? In its constructor, it does something called super. And who still remember what this means? Super. And then parentheses. And then some arguments. What is this? Who still remember this one? What does this mean? Super?
It calls constructor in the superclass.
Very, very good. Okay, so this is super class. This is constructor. Okay. Generally speaking, we always need to do this first. Okay, you call the superclass constructor. Okay. Because in this case, especially for this case, we want to also initialize with the specified first name, last name, social security sales, and rate. Then you call the superclass constructor. Okay. Okay, nothing new here. And the set method, nothing new. Is a get method, nothing. And for this through, don't worry, we will learn later. This is accessor. And then just a review, is it? What does override mean? Can I over here for that get base, I also add override? Can I also write override for get base salary? Add that annotation?
It depends if we have the same get base salary in commission employee.
Yeah, very good. Okay, but here we cannot, is it? Because there is no such method in superclass, is it? But earnings, we have such method, is it, in superclass? And over here, I want to define my own calculation. That's why here I need to override. Okay, override applied to inheritance. Okay, so you override the method, is it here? Is it the superclasses. So here is you apply to superclasses. Define method. Is it? Is it? And we redefine it. Redefine it. Is it because in superclass just commission rate times gross sale? Is it here? I also want to include the base salary. Is it? So that's why over here I need to define my own version of earnings. Okay. And then furthermore, so then over here the question is toString. This toString override which superclass? Is it object? We have toString. Is it commission employee? We also have toString. Is it? So this one override who? Override its direct superclass. Is it? So it's override commission employee. Is it? And this, I believe, I'm not sure if you learned in CS1, okay, string data format, is it? And you can provide a formatted output with the percentage sign, and S then need to match. So S means it's a string variable. String variable. Okay, and here if you see F, is it? F means it's a floating variable. Okay, just match the variable type, and it's .2 means you have 2 decimal point. 2 decimal point. That's a formatting quite useful, okay? And you can check there are more, okay? Okay, so this is base commission employee. Then let's go to the driver part, okay? The client program. Okay, in our client program, so over here, I have a commission employee 1. Is it the variable? This variable refer to what? Refer a commission employee object, LN1. Is it? So as social security number, a commission, sales, and the commission rate. As a commission rate. Okay, anyway, so this is one employee. Then I have this one, commission employee 1. Is it? And I assign commission employee 1 to commission employee 1. Okay, and then I call 1's set last name and change its last name from 1 to then. Okay, then I print, I call employee 1's toString. Okay, employee 1's toString. So what do you think the output will be? Just general.
It's going to change the last name to Ren.
Oh, okay. So it will output as what? As Ellen Wang or Ellen Ran? Ellen Ran. Is it? And some social security something. So it will change. Is it? So commission employee 1's last name changed. Is it changed? Why? It's because in stack, that this is that heap. The heap here we have Ellen Wang. Is it? And the social security something. Is it? And here we have that employee 1 point to this object. Is it? And the employee 1. Where is the 1 point to? That 1. Where did it point
to? The same along 1.
Yeah, very good. Here, is it? It's also point here. That's why when you call set last name, this set last name happens on what? happens on this box. Is it? That's why this guy change it to red. That's it, change it to red. Okay, so this kind of concept, previously I think maybe we also discussed called shallow copy. Okay, this is a shallow copy. Because both refer to the same memory location, okay? Okay, that's the concept. And then next, let's see, over here. Okay, over here, we have commission employee variable 1-3, is it? And it's a commission employee objects, ln3, 1-3, is it? L3, 1-3. And then over here, don't worry about the try catch, okay, at this point. I got to use this, okay. And over here, I do 1-3, is it? But over here, I call commission, I cast it. I cast it, is it? And this is commission employee 1, is it? And I call it clone method. Okay, clone method. So the clone method does what? It creates a copy or a clone, is it, of the commission employee 1, is it? Creates a copy, okay. So that's its purpose. And let's go back to take a look at the commission employee. Okay, commission employee, and over here, this part we understand, is it? The commission employee is a subclass of object, is it? And implements clonable. Okay, later on we will learn. Okay, clonable basically it's an interface. Okay, but we will learn that later, not today. Okay, so here you just make it a note there. Let's see, we do have the clone method, yeah. And for this clone method, okay, the clone method, and don't worry about that, okay. Later on, we will learn of that exception. So anyway, so this clone method is from object class. So object class already define a clone method, is it? And it returns an object, okay? And this method is also protected. Protected, is it? And what do we call here? Implement. We call objects.clone. We call the superclasses clone method, okay? So basically, that's just generally speaking, okay? What it will do, suppose this is some object, is it? And if you call the .clone, and this object, all instance variable, all instance variables are primitive data type. Okay, primitive type or immutable. Immutable, okay. And then if you call the .clone, what is going to happen is going to generate a copy of that, have the same contents. Same contents, but at different locations. So a clone of the original box. Okay, so that's what it did. But anyway, it did create a memory at a new location, okay, with something, okay. So that's what this clone method, and it returns what here, also because it returns the object, okay. And then let's go back to the client program, is it? So here we call the commission employee 1.clone, is it? So that means in heap, is it? We have commission employee 1, is it? Then it's clone, is it? So here is copy of the commission employee 1, is it? It did create. So this is that 1-3. 1, 3, going to point 2. Is it? It's not going to point to E1. Is it? And the commission employee 1 is still point to this guy. Is it? So this time, if you call 1, 3, you say last name Zhujiang 2. Is it? So it will only happen on what? On this clone copy. It won't impact E1. Is it? So if you do commission employee 1 to string, then it's still 1. Is it? You won't change. Is it? So this clone gives us, we call it deep copy. Okay, deep copy. Okay. So that's the concept of deep copy, okay, at a different memory location. Okay, then next, let's see. So here we have employee variable. And the type is what? Base plus this time. So the base plus object is created as Bob Louis, etc. And you call the toString. So this toString is a whose toString? Whose? Because here we have object has a toString. We have commission employee. Is it? Also has the toString. Then we also have base plus commission employee. Is it? So it's a whose toString here.
Base.
Yeah.
Base.
Is it? Because what? Because employee is what? Is base plus commission employee. Okay, so it will call its own. Okay, not its superclass, it's a toString. So now you see that override. You see why we need that override. Is it? So that plays its role, okay? And you can call set base, nothing new, and call employee reset, and earnings. Is it? And earnings. So here earnings, so this earnings, we have 2 earnings. Is it? Commission employee has earnings. Is it? And the base plus commission employee also has 2 earnings, has its own earnings. So this earnings is whose? Commission employee or base plus? Whose earnings? It will call.
Base plus.
Yeah, it's base. Okay, so be careful, it's its own. Because what? Because you call new here. Is it? You call new here, okay. Okay, so that's once again shows the overrides functionality. Next one is a very important concept, okay, another fancy word, polymorphism or the dynamic binding, okay, this 2 words. So in OOP, we have learned what? Encapsulation. And we also learn inheritance. Another feature is polymorphism. Okay, that's the third pillar, third feature, okay, of OOP, polymorphism. So what is polymorphism? Okay, so polymorphy, based on name, is it? It's multiple forms. So it's a kind of one thing can show different forms, is it? So what all of this means can give different behaviors, is it? What all of this mean? So here to call a method called M. So let's first take a look at that M method. This M method, if you take a look, it's quite simple. The parameter is what? Is object, the type. That's a superclass object. What it does is just call whatever the toString. Is it? Whatever the toString. Okay, So it's just do the print line. That print, yeah, print line. So basically call it toString, is it? So if you take a look, the first, what it plug in? The first, it plug in a commission employee object. Is it? The second one, you plug in with what? A base plus commission employee object. Is it? So that a single method, is it? It can take in different type of objects. Is it? Can take type of different type of object. And what's inside its core? It's going to do system.out.print line. Is it? Print line of what? Of that specific object. Is it? So some object dot toString. Is it call that objects dot toString? toString. Is it toString? Okay, and then
I
let's.
have a question.
Yeah, please.
So in the M method, we have object X.
Mm-hmm.
And we can send arguments which are not object, which can be base plus.
Yeah. And can also
it
be
still
employed.
counts?
Yes, still counts. Yeah, very good question. Okay, that's called polymorphism. Okay, like what here it says. Okay, polymorphism. So it allows the parameter type be superclass, like here, object. Then you can pass in. Of course, object itself, it works. Is it? But you can also pass in what? You can also pass in like commission and base. Is it because what? Because they are subclass of object. Okay, so that's also allowed. Yeah, so here is that you can pass any of the parameters subclass. Okay, subclass. So the toString X, is it? You plug in X. So the first time it plug in with what? So X refer to what? So here is that heap. Is it? So the first one you have that, what's the name? M, where's the name M? Oh, we just named CS265, CS265 under second, okay. So let's see. Because you see in stack, you call this method, is it, with X, then you call it again, is it? And over here you create that CS265 commission employee, is it? This is a commission employee, is it? And we also have CS265 underscore 2. This is a base plus commission employee, is it? And here you have this X point to here, here you have this X point to here, is it? To here. And then inside you call that toString, is it? So in this case, in the commission employee, when you plug in, so the toString is whose? Objects. So is the toString going to be objects? Objects in this case. So who's the toString? The question is. And same thing, the toString.
Object.
It's objects. So you think it will print objects. So then you won't get CS265. So what it, so you think the result will be, okay, so it gives the class name, object, some hash code, some hash code. So some 0x something. something like that. Is it? So using that will be output. Then in this case, when I call mx twice, there is no difference. Is it always output? So you will have that output twice. Is that correct?
I guess no.
Yeah. So it will output what? It will output the corresponding, the CS265. Is it a CS26_2? Is it? It will output the corresponding boxes information. Is it? Boxes information. So this is called polymorphy. That's why we call it polymorphy. Is it? So you have two formatting of the two string. Two string. It's their own. It's not objects. Okay, it's not objects. It's their own related with the boxes. Two string. That's why we call it polymorphism. Okay, so over here looks like some single object type should be object, is it? But when you really invoke it, it depends on whatever you pass in. It will call the corresponding subclasses method. Okay, it will demonstrate subclasses behavior. That's why we call it polymorphism. And the other word is, we call this dynamic binding. Is it? It's not determined here, because here is objects to string. It's when you invoke, when you run to that statement, is it? It will know, okay, to call to the bottom box and the top boxes to string. So it's dynamic binding, okay? That makes sense, this concept now?
So this method to string is whose method?
This to string, it depends on, you see here?
Depends on the object we send?
Yeah. So,
makes sense.
Yeah, the to string in this M, it's called commission employees to string. In the second case, it's called base plus commission employees to string, okay? So it call whatever you plug in, okay? That's why we call it dynamic binding, okay? When it run to here, it knows, oh, I'm going, because initially your M, you define it as objects to string, is it? That's why we say it's polymorphism, even though when you define it just to show a single objects to string, but when you really plug in, it allow you, its subclasses object also be plugged in, and their corresponding method is going to be called, okay? That's why you provide overriding. If you don't override, then it will call the superclasses objects, okay? Then it won't show polymorphism. So that's why here we have that override. So override demonstrate part of, contribute part to the polymorphism and the dynamic binding, okay? So that's the relationship.
Also, can you send superclass to be a subclass? So we have right now like subclasses and we send it to object X. So if it will be reversed, does it work still?
No, then you cannot. That's another story. Later on, when we learn generic programming, we will explain in what scenario you can do, okay? But right now you cannot, okay? And then next, let's see, employee is base plus, okay? Here, employee, the type is what? Is base plus commission employee type, is it? And here, the commission employee 2, the type is what? Is a commission employee. Okay, so basically over here, the concept is you assign a subclass object to a variable. The variable type is superclass. That's allowed. Okay, this is allowed. And then when you call employee2.toString. Is it? So then here it may confuse whose toString is going to call. It's going to call subclasses. That's called dynamic binding. Okay, dynamic binding. Okay, so why? Because if you take a look at that stack and the heap, it will be very clear. Heap. Is it? So here we have the base. Base 1. Is it? So that's Bob. Is it? And here is E2. Is it? E2 refers to this object. Is it? So when you call this toString, this method belongs to some object's instance method. Instance method. It must belong to a box. Whose box? This box. And this box is what? Is base class. Or is that a base plus? It's not commission employee. Okay, even though you may say, oh, commission employee, I hear that the type is commission. No, it refers to this memory location. Okay, so that's why over here you can call subclasses. Okay, subclasses. And it's called dynamic binding. Okay, and then next let's take a look. So here we have the employee object. The type is object, is it? And I associate it to what? To a commission employee box object instance, is it? And if you do this check, it will return true or false. It will return true. Okay, because what? Because it is an instance of commission employee type, is it? And if you want to call the last name, then you can cast it. So we can cast it. Okay, to subclass type. Okay, so just to show another usage, okay? And then next, let's take a look at the next one. The next one, oh, we needed to, what's the, so this employer is BBB commission employee, is it? And this EMP2, it's also commission employee, is BBB, is it? And these two have the same contents, is it? And then says it's checks. Do you think this will be true or false? The answer. It should be true or false. Called the equals. So
what's the method?
Yeah. So
what's the method equals what it has inside?
Oh, okay, let's take a look. Then you think who's equal? The first question, who's equal is going to call? Objects?
Object?
Commission employees? Who's equal it's going to call? The first question you need to tell me who's equals it's going to call, because objects has equals. Commission employee is subclass of object, is it? Commission employee is a subclass of object. Let's see, it's equals. Where is equals method? Yeah, here is its equals method. Is it? It just compare with everything. First name, last name, social security, everything. Is it? Okay, then let's go back here. Where is that? Okay, it's here. Is it? So this equals is who's equals? Objects is equals, commission employees equals, or base plus commission employees equals. Whose equals? Whose equals? This is what? Commission employees, is it? Commission employees. Employees equals method, is it? So it's plug in with what? Plug in, not an object, is it? Plugged in with commission employee object, is it? Commission. So it will call the commission employees equals, is it? So definitely it's true, is it? Will return true, is it? And how about this? Equal, equal. It's true or false? That should be false, is it? Because this at a different location, is it? Even though both have the same contents, is it? So, so this is regarding. Over here it just shows what method it's going to call, is it? Whose it is. So when you have multiple classes and the relationship is inheritance relationship, then we need to be careful here. Okay, need to be careful. And you can provide some generic method, is it? And then that's very flexible in this case. Then you can call corresponding. You can just call the method, but plug in with the corresponding objects, is it? Then it will invoke the corresponding class's method. Is it? That's what it shows. And also over here, we also shows, is it? And you can assign a base, a subclass object to a superclass variable, is it? And then later on, when you refer to the method, it will call subclass method. Okay, so this is a concept of dynamic binding. Okay, so today we learned two new words, so keep that in mind: polymorphism and the dynamic binding. Okay, so that's